Hi, welcome back to Math 30-1. Today we're going to do logarithmic exponential functions and how to solve them using logs. Pretty easy because we've already know all the rules, all the laws that we have to do, and how to change between exponential form and log form. So this should be pretty easy. We should be able to cruise through most of these pretty fast here. All right, so let's get started. The first question here is just a little opener. Can we use some of our log laws to combine these into a single log, which is a multiple choice question, or just try to figure out which one is the equivalent one? So let's see what we have here. So if I look at my answers here, they haven't combined any of the log y's together, but it seems like they got rid of all the log x's for some reason. So I'm going to look at just the x parts here and see what if I combine these together, what would happen? So let's see what we have. We have log base 2 of x plus log base 2 of x. And then what I'm going to do with this one here is just so it kind of looks the same as the other ones, I'm going to just drop that exponent down. Here we have a multiplying. We're multiplying two things. This 2 and the x we multiply together within the log. Let's put some parentheses around these. So I could separate those. So if I separate those two things into log base 2 of x plus log base 2 of 2 plus log base 2 of x again. So that's being separated into those two terms there. That's a 2 there, sorry. And then I'm going to minus log base 2 of x. Okay. What we know is, here we have a log base 2 of x plus another log base 2 of x minus 2 log base 2 of x's. So these three terms will cancel each other out. I'll have 2 log base 2 of x's minus 2 more log base 2 of x's. I'm left with this one term here, which is log base 2 of 2. Log base 2 of 2 is 1. Then I have my other term minus log 2 of y. So it looks like it's 1 minus, so it would be d in this situation. Okay, hopefully you paused that before I started the question or tried to do that question before I started doing it and actually solved it. The next one. So the reason we want to talk about these logs is most of the time we want to try to solve an exponential function. But sometimes you can solve an exponential function by just changing the bases. So they kind of match. So you got 25, you got 5. So I could change the 25 to be 5 to the power of 2. And then that would be extra fun. And then I could change this one here. I don't have to change it, sorry. I just rewrite it. So 5 to the power of 2 is a 25. So I haven't changed the expression. But now I have the power rule here. So this would be 5. I'm going to multiply the 2 into the brackets. 2x plus 2. On the other side, I have 5. I'm going to multiply this into the brackets as well. That should be a 1, sorry. 3x minus 3. Because they're the same base, I can drop the bases and just say that 2x plus 2 is equal to 3x minus 3. I could rearrange this to try to figure out what is x. I'm going to minus the 2x over, add that 3 over, x equal to 5. You could try to verify this and see if it actually does work out. I'm not going to bother just for that, just for time. I'm not going to bother. All right. Now, we could solve for an exponential function if the bases are the same, but the bases are not the same. So if they don't have a common base, so if I can't find a base that would be the same between the two, maybe just because I'm lazy or something, I could solve them by using the laws of logs to do this. Now, there's a few different ways to do a question like this. I'm going to show you the two ways here in this first question, and you just kind of pick the one that you think is the easiest or the one that you can actually do in certain situations, like the question C, you can only do it one way, and say they would B, you can only do one way, but questions A and B, you can do two ways. It works out just fine. Actually, you could probably do it for all of these the same way if you want to try it. Here you're trying to solve for x. Right? Now, I can't solve for x because it's in the exponent this way. So I can change this into exponential form. So remember that rule where you can kind of switch these two spots. I got a base of 4. So it's log base 4 of 12 is equal to x. And then we're done. You just punch in your calculator to get an answer. So log base 2. If I want this as the exact answer, this could be my exact answer. Because log base 4, let me just go to the base here, of 12, I don't think is a very nice number. 1.79-ish. 1.79, yeah. So this is approximately 1.79, but it could be written exactly as a log base 4 of 12. So that could be an exact answer. You might see this later on when they say, what is the exact answer of x? That is the exact answer. It's like saying the square root of 2 is an exact answer. You just leave in the function there that you say you're going to do it. They give you the answer if you did it, but you're just not going to do it. Okay? That's one method, right? You could just change it using exponential form. Another method that mentioned up here, well, there's two methods here. You can graph both sides, but I'm not going to show you the graphing side. That's easy enough. You just graph the left side, graph the right side, find out where they cross each other. We've done questions like that before. Another method here is to take the common log of both sides. So rather than just change it to exponential form, we could just change it by just saying, like we did before in a previous question, just take the log of both sides. So there, I introduced the log of both sides. Like, remember, that's like taking the square of both sides or taking the square root of both sides. You just take the log of both sides. Because you did that, that x is now an exponent inside this log, so that x can now drop down in front. So got my parentheses there. And now to just get the x by itself here, now it's x times log 4. I can now divide by log 4. So there's an exact answer. If you want to, you can combine this using that base law we had before. Remember that if you're dividing by a log, as long as these logs are the same, this could become a new log with that base. That's the same answer that we had before. Log base 4 of 12, log base 4 of 12. So it works out the same way. That's probably one of the easier ways to take the log of both sides. And when you take the log of both sides, you don't necessarily have to isolate for the thing that has the exponent on it, because we can use our log laws to kind of separate that for us. So I'm going to look at this one here. Now, you could, like, if you're going to use the change into exponential form, you're going to isolate for the exponential part and then change it into exponential form. So I'm going to do the same thing. We're going to do the two different ways, and we're going to see if we get the same answer. I don't know. We'll see. Hopefully you do. So if I want to, I'm going to rearrange this. I'm going to just divide the 2 over and get that exponential by itself. Change it into exponential form. So this is log base 3, because the 3 here, of 6 is equal to 5x. And then I'm going to solve for x here. I'm just going to divide that 5 over to the other side. Log base 3 of x, or 3, divided by 5. And there's my exact answer. It looks pretty good. I'm okay with that answer. Now you could also take the log of both sides like we did in the previous one. Right? I'm going to use a red to separate the two lines here. So if I take the log of both sides, like this one over here, now I could do it in this stage here where before or after I do my logs. It doesn't really matter. I could do it before, I could do it after. So I do let's say I do the after way first. So I take the log of both sides after I divide it by 2 on both sides. I take the log of 3 to the 5x is equal to the log of 6. I could drop that down. Divide the log 3 over. And I could also, at this point, I could also divide the 5 over as well. Okay, so I can do that. You can see what I did there. I divided the logs. When I divide these two logs, I can change the base to that new log. I guess that's another way we could have solved the previous question. Because they're both the same base, I can combine them together and make a new base. Yeah, we did a different way before. You'll see that with that log 1,000 and log 100, or log 10. I think I could have done that way too. Combine them together, change into one base, and then thought of that question instead. I think it'd end up being 3 as well. All right. Now, you might see this later on, like where did Johnny go wrong in some tests? Like, did Johnny do something wrong? Now, it's not wrong not to divide over the 2 first if you take the log of both sides. It is wrong if you try to do the exponential form. Like, you can't really do exponential form that way. But if you take the log of both sides before you do this, and I'm just going to write it down here. You don't necessarily have to write this part because we've solved it 2 different ways. There's no real point to do it again. But you could see that if you try to do it that way, if I take the log of both sides, I'll just introduce a time sign there rather than what we had before. Okay, so I'm going to separate these two logs. It does add a little bit more work. You can see the work we're adding here to ourselves. Oops, sorry, that should be a 5x. Let's put that there. All right. Okay, and then I'm going to subtract over this log 2. So I got log, I'm going to drop the 5x down. Okay. And when I subtract over the log 2, I get this situation. Uh-oh. Now, when you minus 2 logs, you divide what's inside. So this becomes log 6. Then I divide that log over, the log 3, that becomes log base 3 of 6 again. And that's equal to 5x. And then I divide the 5 over. You can see I got the same solution. Just a bit more steps because you had to do this multiplication rule where you separate into adding, then you got to subtract over that piece. And then you got to recombine those back together because now you're dividing, minusing, now you divide what's inside, you get the 6. Gets you the same answer in the end, but it's not wrong to do that. So if Johnny was going to do that, that's not where his mistake was. He probably did some other mistake somewhere else. All right. And we just get rid of that now. Okay. You might want to give yourself a little bit more space for these next ones. I don't think I gave you enough. Let's see how we can space this out nicely. All right. Now, if I can't change the base to be the same, like all these ones, I can't change the base to be the same, and they have an x in both exponents, you could use our exponential form here. Now I'll show you both ways. You just decide which one you want to be the base. You want this to be base 5 or base 3. If I did it by, say, that way, so say this is the base I'm going to use, I'm going to say log base 5. And what's on the other side now becomes this piece here. And then that 3x is now over on this side. All right, so these two things switch their spots. This whole piece and the exponent are going to switch because I use the bases of 5 here. I got it done the other way. I got to make the base 3, and the 2x minus 1 comes out the other side. That's fine. Doesn't really matter how you do it. Now that exponent's now going to drop down. Then you're going to multiply with log base 5 of 3, 3x. Now it gets a little confusing at this point because you got to think, how do I get the x by itself? It's going to get kind of ugly. To get the x by itself, I need to figure out a way to get rid of these parentheses here. And then I got to move all the x's to one side. So if I did that, I'm going to multiply this in. So I get 2x log 5 of 3 minus log 5 of 3. Sorry, I ran into that equal sign there. There should be a 5 there. Maybe I'll fix that. Okay. Then I'm going to move this log over to the other side, or vice versa. I can minus the 3 over this side. Doesn't really matter. I want to get all the x's to one side, so I'm going to move this whole term here, right? All of that to the other side. So I got minus log 5 of 3, and I got 3x minus 2x log 5 of 3. Now it's going to get kind of ugly at this point. How do I get the x by itself when this x has this weird log 5 of 3 and a 2 in it? I can't just subtract these two and get 1x because this is all one piece right here. Right? So I can't just subtract them because they're not like terms because this log 5 is in the way. What we could do though is factor out of what's in common between these two. And there's an x in common because that's what we want to solve for. So I'm going to solve for an x here and factor out that piece. I got 3 minus 2 log 5 of 3. Now 2 times log 5 of 3 is a number. The reason I'm leaving it this way is because maybe I want an exact answer later on. I'm going to run into this space over here. Sorry. That's equal to what we had on this side, negative log 5 of 3. So it's negative log 5 of 3. Now to get the x by itself, I'm going to divide by everything in these parentheses here. And there we go. There's an answer. Now there's a few different ways to do this. They essentially just kind of work out the same way. They all look pretty similar to that answer. You can make them look a little bit nicer sometimes, but this is pretty much the way it's going to end up looking most of the time. And I'll show you the other way to do this. So I'm going to erase this. You can just leave this as in your notes if you wanted to. I'll just show you a different way. Get the same answer. Right? Well, I guess I could have done for the previous one, the next one on the next side there. Well, that's changing to exponential form, but you can also just take the log of both sides. So if I just took the log of both sides, let's use log base 10. You get 5 to the 3x, and then over here I got log base 10 of 3 to the 2x minus 1. And then I could drop both these exponents down. Oops. So we have 3x, and then it's the log 5. And then I can take this exponent and drop that down. This be 3. Okay, log of 5. Okay. Again, I have to solve for x here. So we're going to look at this and say, okay, how do I solve for x? I need to get everything that has an x to one side, but I have these parentheses in the way, so I'm going to multiply in this piece. All right, and then I realize that these two have symmetry. Now, there's other ways to do this. So you divide over, say, what the log 3 over. If I divide over the log 3, this becomes log base 3 of 5. Or if I divide the other way, it becomes log base 5 of 3. Either way, it doesn't really matter. You can combine those two logs. But in this case, I didn't bother combining the logs. I just multiplied them into my brackets. So I use a little bit of distributive property there. I'm going to minus this over to the other side. I don't know why I wrote that equal sign there. It's going to be a bit longer than that. Okay. That's one way. And then I look at this and say, how do I get my x by itself? These are not like terms, like 3x log 5 is different than 2x log 3. So that technically I could subtract them if I knew what these numbers were, and they're just numbers. Log 5 is a number, log 3 is a number. But I'm just going to do this instead. I'm going to factor out, because that's what you're technically going to do, is you're going to minus whatever's in front of the logs, or in front of the x's here. So I'm going to minus 3 log 5 from 2 log, or the other way around, minus 2 log 3 from 3 log 5. All right, and then I want to get the x by itself. I'm going to divide over this piece on the bottom here. So I'm going to run out of space here, but you would divide all of that to this side, that side, and then you would have x by itself. And there's your answer. In exact form, you can plug in your calculator to get a more approximate answer, but usually we look for those exact answers when we do some of these questions. I'm just going to do the same thing on this one over here. So you notice that in this situation, let me just get rid of that. Notice in this situation when I did that, I put these parentheses around this exponent that we dropped down, because there's a common mistake here when we drop the exponent down, we might forget those parentheses, and then you may not multiply it over to the 2x when you should multiply it over the 2x, not just the negative one here. So you're going to see that when I do this one here, when I take the log of both sides. I take the log of both sides. I'm going to drop that exponent down. I might as well just do it in the same step to save myself some space. So take the log of both sides. Okay. We need to get rid of the parentheses. Again, there's two ways. I could divide the log 3 over to get rid of the parentheses here, but I still have them here. I'm going to multiply it in. Or I could divide the log 5, or I could just multiply them on both sides. Use a little distributive property. So I get x log 3 plus 2 log 3. And then I have 2x log 5 and 3 log 5. Now those are just numbers, but they're ugly numbers, so I'm not going to punch in my calculator. I'm going to move everything that has an x to one side. Doesn't matter which way we go in this situation, so I'm just going to keep the log 3 on this side, but I'm going to minus the 2x log 5 to this side. I'm going to keep the 3 log 5 on this side, and I'm going to minus over the 2 log 3 onto that one. Now you notice I kept the parentheses here. When I multiply up here at the top, I put parentheses around this, so this log 3 applies to both the 2 and the x. and the log 5 applies to the 3 and the 2x. If you forget those, you might forget that it applies to the 2x. So emphasize you're putting down these parentheses here. These are very important. Okay. Okay, you look on this side, these both have an x in common. So I factor that out. Let me just rewrite this side. And then I divide this really big piece here. This is just a number. That's all it is. I'm going to divide that piece over to the other side. That's a log there. Okay. Big bracket here. Log base 3 minus 2 log 5. And that's pretty much it. I could probably combine these together because they do have, I can use some log laws here. I could raise these exponents up here, combine these and make them look nicer. I mean, I don't see why I couldn't. Maybe that's a good idea. Maybe I'll try to combine these to make these look a little bit nicer and see what that looks like. So the top here, this would be log. Because I am multiplying these two together, I get 5 to the power of 3. We've raised the coefficient up as exponent. I'm going to divide it by 3 to the power of 2. Now, I don't know if that actually makes it look nicer, but it's just making it into one log, though. On the bottom, I would have log 3 divided by 5 to the power of 2. And that's what's on the bottom there. That doesn't look very much nicer. I'm sorry I even tried. I'm just going to, maybe I'll just get rid of this. Or you can leave it in both those forms. You can find out this is 9 and this is 125. So 125 divided by 9. But you can't really do anything. There's no rule for dividing two logs unless you want to just change into one base. Right? So this is technically a change base formula now. So this could be some ugly number. You have a little base here. My base would be 3 over 25. And then this would be 125 over 9. Okay, so that could change into one single log that looks like that. But any one of these steps I'm okay with. I'm happy with this one, or this one. They're all exact answers. They all represent x. The last one's just nice because it's just one log and they can punch in your calculator. That's pretty good. All right. I think that should be it for this video for now, because that was a lot, right? This is solving exponentials using logs, but now we're going to use log laws and maybe change it into exponentials to solve for logarithmic functions. Okay. I'll see you next video. Bye.